Our next speaker is Matilde Espinasse, and she'll be talking about the X-ray binary XTE J1748-288 and about the jets. Take it away.
So, hi everyone, my name is Matilde Espinasse and I'm a PhD student with Stéphane Corbet. And so as Vicky said, I'm going to present the work I've begun to do on the X-ray binary 1748. So this X-ray binary is presumed to be a black hole X-ray binary, and it's found in the galactic center direction. We think the mass of the black hole might be more than 4.5 solar masses, but basically that's the only thing we know about the source. We don't know its distance or stuff like that. And it was discovered quite a long time ago during an outburst in June 1998. So maybe you heard about the source already. It was detected first by RXTE and then by BATSI. And at the time, it was quite a bright source. So it reached around 600 millicrabs one day after the discovery. However, it became soft only 2 days after the discovery. So with what we know now of X-ray binaries, we can think the beginning of the outburst was missed, so sadly. Then a radio counterpart for it, which is what I'm interested in, was discovered by the VLA 3 days after and was resolved 1 week after. So at the time, they concluded on the presence of a one-sided jet ejection and estimated the lone dates of around the 1st of June. So this also illustrates that we missed the beginning of the outburst. So here is a plot for the X-ray outburst from 1998. So you can see the X-ray light curve is basically a typically X-ray light curve with a quick rise, then an exponential decay, and then the source goes back to the out state. But what I'm interested in is the radio data. So as it is data from 1998, of course, it has already been looked at. And the first thing that was published is actually a press release from the NRO. So this is a screenshot of the press release from the time. And in this, they conclude that so this source was a black hole candidate with emitted a relativistic one-sided jet. And as they see the jet moving and then stopping abruptly, they conclude that it has collided either with the ISM or with some previous ejectors that left material there. And so at the time, it was one of the first observations of such an interaction with the ISM. Of course, now, as Rob stated, and so Tom and Francesco, it's a quite well-known phenomena. We've seen a few sources for which we see this interaction with the ISM. So after this press release, there were meetings about this. So maybe you heard about it, but there was no real paper following this discovery. And then another paper focused on the radio data a long time after. So in 2007, Broxop et al. Focused on 7 ATCA observations and also 6 VL observations when they were simultaneous. And they found that the radio sources, well, sadly were not resolved in ATCA, but they were resolved by the VLA into 2 east-west sources. So this paper focuses mainly actually on polarization. And they find that there is quite a high level of polarization in this source. So when the source is back to the Earth state, it's still around 23%, so quite high. And so even though ATCA cannot resolve it, they conclude on the presence of remaining jets in the source. So that's why we're interested in the source with Stéphane. So my job is to focus on the VLA data, which was not analyzed much, to study the jets and mainly to see if they interact with the ISM. So Rob really presented this very well yesterday, so I'm not going to take a long time on this, but jet ISM interaction with X-ray binaries. So it's what we see, for example, with the source from Francesco, is when the jets slow down or sometimes reappear due to interaction with the ISM because of particle acceleration. And so we can see it in radio, for example, here with H1743, but also in X-rays with 1550. So we can see here in the jet, which is interacting with the ISM and even develops a nice, very beautiful tail behind it due to the interaction. And so when you do a spectrum of this interaction, we find that it's a synchrotron radiation from the radio up to the X-rays in general. So as Rob stated yesterday, we have now a few sources for which this has been observed. And so we want to know if 1748 is a new one to add to the list. So for that, we have VLA data. So the VLA campaign, as I said, was started on the 7th of June, so a few days after the discovery of the source, and was carried on for 9 months for the first round of observations. And then some sparser observations were carried on for years and years afterwards. So we've got lots of data. And it covers 5 radio bands. So from the L band, so 1.4 gigahertz, up to the K band, 22 gigahertz. So we've got a huge range of frequencies, which is quite interesting for this to observe this source. So with this time schedule and bands, it makes a total of 224 observations radio. So that's good news because it means when we see the jets, we'll have plenty of data about it. Bad news is, of course, it takes time to reduce. So I'm going to present only preliminary results. These data sets, however, has some flaws, some difficulties are associated with it. So the first thing which we'll talk, maybe speak only to radio observers, is that the flux calibrator is missing in around half the observations. So it's something we need to do the radio data calibration. So it means more work to find another one and try to get radio data calibrated. Then, so this target, as I told you, is in the galactic center direction. So for the VLA, it is quite low elevation sources. So it means data are not as great as we could get from another X-ray binary, which would be higher in the sky. Moreover, it's data from 1998. So at the time, the VLA was working a lot in snapshot mode. And snapshot means observation of 3 to 4 minutes. And so it means in radio, a bad UV coverage, so not much data. And so it makes also the data set a bit difficult to get great image from. Also something to keep in mind is that it's old VLA again, so we don't have a huge frequency range. We have only 2 channels of 50 megahertz, so we can do spectral analysis like we used to do now with radio data. And due to all these reasons, it means to get great images, we need always to do self-calibration. So same thing for radio observers, you'll know it means we lose the absolute position of the source. So to identify which component is which between the core and the jets, that's a problem. Well, however, we're still able to get some preliminary results. So here's the total study of the total radio flux. So on top there, I put you back against the X-ray light curve. And here you've got the total light curve in radio in the C-band. So you can see we've got a clear radio peak that happens 10 days after the X-ray peak. And then the flux decreases. And then we've got another increase in the radio flux on the plateau when the source is back to the Earth state. So we think maybe this may be linked to the fact that compact jet has reappeared, and we might be able to detect it also alongside the jets. The good news is, well, in X-band, which you have on the left there, the radio light curve looks the same. So then with this peak in C-band, we try to estimate the energy in the radio flare. So we're using lots of assumptions with the peak rise time, the total flux on the peak, and a distance. So we suppose what would be 8 kiloparsec because we don't know it. We get an energy estimate of 10 to the 43 erg. So that's a bit high compared to what we get for other sources when we estimate the energy in the radio flare. In general, it's like 10 to the 42 erg. But as I was saying, there are lots of assumptions in there. So before concluding it's a super energetic source, we need to study this much more. Then another thing we could do is study the proper motion of the sources. So here are 2 images found in the X-band around 3 months apart. So you can see in the beginning, we can't resolve different sources in X-band. But as time goes by, we see here we see clearly there are at least 2 sources. And we hope with higher frequency bands, of course, we can resolve this more. But we could already study a bit the proper motion of the sources. So as you can see, these plots, which are angular separation versus time, are preliminary because they don't look that good. One interesting thing to notice is that the dotted lines there are the changes in VLA configuration. So at the moment, we're struggling a bit with the changing in configuration and the position of the sources. So we need to look into that. But still, the global trend is nice, and we see sources that are getting far away from each other, which is what we expect. So this is C-band, sorry, and this is X-band on the right. If I zoom in to the beginning of the plot here, so you can see here the zoom in the C-band. We think maybe we can see a quick motion there, and then the jets slowing down. However, we can't see it in X-band, so maybe it's not right. This needs to be confirmed. But if it's the case, it confirms actually what's been seen in the literature. So in ATELs and the press release that the jet was moving quickly and then slowed down abruptly. So I invite you to wait for the next results to see if we confirm this or not. So of course, we've got future plans. So the first main one is to finish this analysis because it's still very preliminary and not over. And as I said, we have KU and K-band data also. So that's really interesting because we'll get a great resolution at these bands. However, because it's higher frequency, we've got atmospheric issues at the moment. So the calibration is difficult. So preliminary result I can tell you is that we get at least 2 to 3 sources in K-band, maybe even more. So it will mean this source has probably a multiple ejecta, but we're not sure yet. And another interesting thing to keep in mind is that even though these are old data, this source, of course, still exists. And it was detected in January, last January, in an ATEL. So during a galactic survey, they detect quiescent flux around 0.1 Jansky. So maybe it's a source for which we can do measures of the steady quiescent flux, which is always interesting. And thank you for your attention.
Thank you. Any questions in the room? I don't see any hand up. Do we have something on Zoom? And nothing yet on Slack. So maybe I'll start off. When you meant the study of proper motions, was that just between blobs in the one source, or was it actually the core of the source moving?
So at the moment, actually, well, we don't know because as I told you in radio, like due to cassette calibration, we lose the absolute position of the source. So we don't know which source is a core at the moment. So we detect 3 sources. We don't know which one it is, if it's a core and 2-sided jet, or as they said in the press release, a 1-sided jet with different ejecta. So at the moment, I'm just doing the proper motion of the sources one between another because I can't know which one is which.
Thank you. Let me just have a look and cover all bases. Nothing on Slack yet. Okay, I see a hand up in the room.
Hi, this is Julia. I have a question. Is it the ejection related to a huge flare like for the other sources? Because I missed the level of the
so I don't have slides anymore, but yeah, we got a peak, well, the X-ray peak, of course, of the outburst. And in radio, the peak reaches around 0.5 Jansky in C-band, so quite a huge peak, a bit the same values as 1348. Okay. So I can show you the light curves again, so you can see in radio, this is a C-band and this is the X-band. So
and X-rays, you don't know. What about the X-rays instead?
The X-rays, so you've got
on
the top here is RXT, RXT ASM data. Okay, so you can see the peak. And as I said at the time, they found it was quite bright source because it was 600 millikrabs at the time. So for them, it was bright.
Okay. And do you have also polarization for this?
No, at the moment I don't have it. Well, they did it with ATCA in 2007, Brox et al. So it's where they conclude, because with ATCA they can't resolve the sources, the jets, but they conclude they are jets because of the polarization, which was up to 23%. Still in the hard state, so it's too high for the compact jets. So that's why they think they are jets.
Okay, thank you.
One final question from Zoom. Federico, you can go ahead.
Hi, Federico Vincentelli. Did you manage to do also a radio X-ray correlation plot diagram?
I think they want to see the radio X-ray correlation.
Is there? Did you manage to?
Oh, so we don't know actually on the radio X-ray where the source is at the moment. So if the question is it radio loud, radio quiet, we don't know. Because we don't have like simultaneous observations. There is RXT data from this source. So when we have the final radio data, we can compare and see if they are simultaneous to put it there. But at the moment, I don't know where it is actually.
Okay, thank you.
All right, that's it. Let's thank Matilda again.